Hello everyone, I'm Flora and this is my System Software and Compiler Design Lab experiment number 7. So today's experiment is to do predictive parsers. To perform predictive parser, a given string will be given. We have to parse the string and see whether that string satisfies the given grammar or not. So basically what we have to do, there are types of parsers: top-down parsing, bottom-up parsing, and what I have implemented is a basic parser, which would be a top-down parser. So the parsing technique is regarded recursively, so that we are able to determine whether the parser accepts the string or rejects the string, and it uses context-free grammar, which is recursive in nature. So in this experiment of mine, I have used Java to build my parser. What I have done is I've initialized some array size, and then I have read the input from the user. I have stored the inputs, and then whenever I input the string, when the terminal I input, I compare it with the generated table, parsing table that I've created for one particular non-terminal. From a non-terminal, when a terminal appears, where does the next state it goes? So where does the terminal take one state to the next state, or whether it's stuck in the same state, whether the parser accepts the string or not. So in this, what I've done is I've accepted the number of terminals, the number of non-terminals, number of starting non-terminals, and then all the terminals that are required, whether there are n number of terminals, or there are n number of non-terminals, end state, final state, and initial state. Then I've asked them to enter the table. That is for one, if suppose I've start from A and my terminals are small a and small b. So for at a given time from A, when I encounter a small a, where does my machine take me? To which state? So that is entered from the user, whether it's a null state or it takes to another state. Similarly, the entire transition table is made, and the input to the parser is given by concatenating with the sign, hash sign, or any sign depending on the user. And then I have dotted out the parser, whether it's passed or it's not passed. So when I compile this file, it will ask to write the number of terminals. So for my given experiment, given question, I have to write the number of terminals, suppose 6, number of non-terminals 5. Then it will ask to enter starting non-terminal in the grammar, enter all terminals simultaneously. So whatever terminals we have. So for a given experiment, that what I have done, I have given all the terminals that are there, that is small a plus into, then brackets, and then the dollar sign. And then it will ask us to enter all the non-terminals simultaneously. So all the non-terminals such as E, A, T, B, F. So when we enter that, then it will ask us to enter the row entries of the transaction. As I said, what is a row entry? So we'll have to give the row entry of the transaction. So after feeding all the details, this is just for the first row, that is for the column, for the row where we have our non-terminal state as E. Similarly, every non-terminal state should be fed. So once that is done, we'll be generating a transition table as shown in the picture. So this would be the transition table that would be generated. Once that is done, we'll have to give the input that the user is given. So for example, when we when we input the string to the users, for the given string a plus a into $8 hash, so our stack that is created will represent the output of the parser. So when a, the first symbol comes, so what is the equation that we have used? A, E goes to TA, and if that is satisfying, the next string, next character of the input string is accepted. So this goes on till our string is accepted or rejected. That would be the final answer for it. So this is predictive parsing. Thank you.